now. This is very theoretical. This is there in our ebook. Please go and read. There is nothing special to understand in this. What it is saying is, I'll define a couple of things. Rest you can study on your own. Okay. The sum of two rational numbers is a rational number. So sum of two rational numbers. If I take any two rational numbers, if you add them, you will get another rational number. So anything, something like even if you have 2 by 3 plus 4 by 5, if you add, will I get a rational number or a irrational number? I'll get a rational number. So addition of rational numbers. What is this property called? Shomik, I'll tell you what is an ebook at the end of the class. Okay, I'll talk about that. Okay, the sum of two rational numbers is a rational number. What is this property called? The sum of two rational numbers is once again a rational number. What is that, such a property known as? In mathematics, you learned it already in your 6th and 7th standard. Come on. Very good, Kirtana. Very good. Such a property is called closure property. Closure property. Very good. So what is a closure property? Always a particular set of numbers. For example, here in this case, we are talking about rational numbers. So we have two rational numbers, let's assume say A and B. Sum of those two rational numbers is equal to C, and that C belongs to rational numbers once again. If that also belongs to rational numbers, that also belongs to rational numbers. That means they are from a same set. Rational numbers adding up giving rational numbers. Therefore, it satisfies what is called a closure property. We call it as closure property. Okay. So in future classes, we can discuss other properties. There's something called associative property. There is something called, what do you call, commutative property. Will come there later. So for the moment, it's a closure property. So addition of rational numbers satisfies closure property. Similarly, subtraction of closure property. The difference of two rational numbers is also a rational number. If you subtract two rational numbers, whatever number you get, it's always a rational number. So good, Xiaoming. Very good, Xiaoming. Good. Now, the product of two rational numbers, even if you multiply two rational numbers, like 2 into 3 will give you 6, 1 into 5 it will give you 5. Even if you multiply, say, 2 by 3 into, say, 1 by 2, what will 1 by 5? Let's take 2 by 3 into 1 by 5. What is 2 by 3 into 1 by 5? 2 ones are 2, 3 5s are 15. So multiplication of two rational numbers, you're getting 2 by 15, which is also once again in the form of P by Q. So does it satisfy closure property on multiplication? Yes. Multiplication of rational numbers satisfies closure property. Okay? You understand what am I teaching you? All of you. Good. So now, division of rational numbers. If you take rational numbers, say let's take any rational number. Here he has given you example of 4 divided by 2. 4 divided by 2 is 2. Once again, it's a rational number. Even if I divide, say, 2 by 3, if I divide by 1 by 5, how do we calculate 2 by 3 divided by 1 by 5? You know it is 2 by 3 and your 1 by 5 turns. That is, it becomes 5 by 1. So that becomes 2 5s are 10 divided by 3. Once again, 10 divided by 3. Is it a rational number? Yes, it's a rational number. So you can see rational numbers satisfy closure property for addition, subtraction, your multiplication as well as division. So that's a beauty of rational numbers. That's the beauty of rational numbers. That's not the case with everything. Like for example, in natural numbers, subtraction of natural numbers doesn't hold closure property. Because when you subtract two natural numbers, say for example, you have 2 and 3. 2 minus 3, what will that give you? Minus 1. Is it a natural number? No. So in case of natural numbers, closure property doesn't hold good in subtraction. Whereas in addition, it holds good. For example, you have natural number 2, 3. 2 plus 3 is 5. Is it a natural number? Yes. So addition of natural numbers satisfies closure property, whereas subtraction of natural numbers doesn't satisfy closure property. Do you understand the logic? Now, do you understand what a closure property is? Everyone, say yes in the chat box quickly. I want to see everyone mentioning yes. Good. Brilliant. I like that. So if you just concentrate here now, let me complete irrational also, you'll understand. The sum of two irrational numbers may or may not result in an irrational number. Because root 2 plus minus root 2, because minus root 2 is an irrational number. By the way, if your root 2 is irrational, your minus root 2 is also irrational. So on your number line, okay, by the way, we were discussing number line, we just came off. Let me do that. So rational numbers are also on number line for your kind information. 1 point something, they, for example, root 2 will be 1 point something, some value, but that some values, it's somewhere here. It's somewhere here. So it will always be on a number line. So on your number line, this number line is a number line of real numbers. So it will be most of the numbers are rational numbers, and there are irrational numbers in between here and there. So there are many, even irrational numbers are also infinite, but they are there on the number line only. So on the number line, like we have infinite rational numbers between any two rational numbers, there are infinite irrational numbers also. I hope you're getting the point. I hope you're getting the point. But overall, rational numbers and irrational numbers, they are taking care of your entire number line. They are taking care of your entire number line. So that is called real numbers. So there is something called imaginary numbers. If you remember, I was talking about that in my last class. Let me go there for a moment. So I was talking about what is called imaginary numbers. We discussed that. I'll just share what they are imaginary numbers. So for example, we have number like, say, let me put this one. X square minus 1 is equal to 0. Square of a number minus 1 is equal to 0. So we write this as x square is equal to 1. So square of a number is equal to 1. What is the value of x? X could be plus 1, because plus 1 whole square. If you multiply plus 1 whole square, 1 into 1 is 1. Even if I multiply minus 1 whole square. So what do you mean by plus 1 whole square? That means plus 1 into plus 1 will give you 1. Minus 1 whole square, minus 1 into minus 1. What is minus 1 into minus 1? Once again, it is 1. So when x square is equal to 1, in this equation, if I see this as equation 1, in this equation, the value of x could be plus 1, the value of x could be minus 1. So the value, when I draw this number line here, in this x square is equal to 1. So this could be your x, this could be your x. So your x satisfies these two values. It could be minus 1, it could be plus 1. So in this equation, x square minus 1 is equal to 0. The value of x could be plus 1 or minus 1. Whereas, if I have an equation like this, x square plus 1 is equal to 0. Now, x square plus 1 is equal to 0. If I write it as, now if I take x square is equal to this plus 1, if it goes on the right hand side, it will become minus 1. Now, x square is equal to minus 1. Can a square of any number give you minus 1? Any real number? Like for example, can x be equal to 1 in this case? Can x take the value of 1? No, because 1 square is 1. It cannot be minus 1. Can x take minus 1? Can x take minus 1? No, because minus 1 whole square also once again will give you 1. So basically, x square cannot be equal to minus 1. So x square cannot be equal to minus 1. So what mathematicians did is they introduced an interesting number called iota. That's what they call it as. So basically what they did is they said if in this, x square is equal to minus 1, basically x is equal to plus or minus root of minus 1. So you need to calculate. Here if you look at in this case, in this case if x square is equal to 1, that leads to x is equal to plus or minus root of 1. We know root of 1 is 1. Whereas in the second case wherein x square plus 1 is equal to 0, your x square is equal to minus 1. So your x will be equal to plus or minus root of minus 1. So but we don't know the square root of a negative number. Square root of minus 1 is not known to us. It's not a real number. So square root of 1 we know is 1. Square root of 1 is 1. Square root of 4 is 2. Square root of 3 is 1 point something. Square root of 2 is 1.414. So all those are defined numbers. But square root of minus 1 we don't know. Square root of minus 4 we don't know. Square root of minus 2 we don't know. these numbers are, this root of -1, mathematicians said root of -1, they defined it as I. Because they defined root of -1 is I, so root of -4, when they calculated, it will become 2I. So like that, the imaginary numbers were defined. So I'm just, for knowledge sake, I'm explaining, this is not required for your class. I'm just defining this. If this is called a real axis, this is called real axis. This is positive real axis. This is negative real axis. This is on the negative side. What they did is they created a imaginary axis. And like 1, 2, 3 on this line, they created what is called I, 2I, 2I, 3I, and so on. That's an imaginary axis on vertical line. And they created what is called -I, -2I, -3I, and so on. So they have created what is called an imaginary axis. So when real numbers and imaginary numbers come together, they are called complex numbers. That is something that you will learn in your higher standards. For now, you just need to know there is something called real number axis, which is the real number line that all of you know. And you also should be knowing that there's something called an imaginary axis, which is perpendicular to this particular axis. And that particular axis is called imaginary axis. Okay? Make sense? Very good, Kavya. Very good. That's wonderful. That's wonderful. Okay, so that leads us to what is called, so the rational and irrational, the sum of two rational numbers may or may not result in a irrational number. Because see, you can see in irrational numbers, plus root 2 minus root 2, that will give you 0. Now, is 0 a rational number? Yes. So here, irrational numbers, when they are adding up, they might end up giving you a rational number also. Okay, so the closure property doesn't hold good here. Not always. Whereas you can see 5 root 2 plus 3 root 2. 5 root 2 plus 3 root 2 will be 8 root 2. 5 apples plus 2 apples or 3 apples will be 8 root 2. Therefore, it's an irrational number. Correct? So you need to understand that. Just go through this. Now, where is this available? Shaumik was asking me, where do you get this? This is there in our ebook. If you go open your app, in the app, there is something called math section. In the math section, you will have all your chapters. Like our chapter that we are doing now is rational numbers. In that, you will, if you click that, you will see there are videos, there are ebooks available. So you can just go through that. In that ebook, you will find this. Okay, along with ebook, there are some exercise sheets also for you to practice. Okay, good, Shaumik. So this thing, I'm not wasting time here because these are very fundamental. I'm sure most of you know. There is another fundamental which every one of you should be knowing. For each rational number x, one and only one of the following is true. This is also not a great property to learn or remember, but it's very fundamental. What it is saying is every rational number is either greater than 0, or it is equal to 0, or it is less than 0. Wow, what a great knowledgeable point. But it's very simple. I'm sure everyone understands this. Every rational number is either a 0 or it should be here. That means it is greater than 0. It should be here, which is your x should be less than 0. Your x should be either equal to 0 or x should be greater than 0 or it should be less than 0. Very complex. Why Kavya? Why complex? Was it sarcastic? Yeah. Good. So every rational number you all know. So that is, yeah, good, Kavya. That's wonderful. So similarly, you'll get to know that if you have two rational numbers, x and y, if you have two rational numbers, x and y, what will be the relation between them? Either x will be greater than y, or x will be equal to y, or x will be less than y. Wonderful. Even this is a great knowledge. So similarly, there's something, oh, Arya, what you are unable to understand? Now don't tell me, that is also sarcasm.
Sir, that's sarcasm.
Okay, good.
But sir, it's actually quite complex. Like
Why
if you go deeply into this topic, like about rational and irrational,
correct.
It can get like pretty complex.
Yeah. So when we discuss problems, we'll understand this. But in terms of learning as a concept, I need you to quickly know that any rational number will either be less than 0 or greater than 0 or equal to 0. Similarly, when we compare two rational numbers, one has to be greater than the other, or it should be equal to the other, or it should be less than the other.
Yes, sir.
Okay. I hope everyone understands this. So these details, they are very theoretical, which in the context of our class, I'm sure I know all of you, so I don't think we need to spend much time on this. So if anyone needs any help on any of these ideas in my next class or whenever we meet next time, you can always ask me, or you can always post it in the doubt forum. So on our app, there is a feature called Doubts Forum. You can post doubts there. Okay, so you can use that also. Okay, good. So let's get on. Now, distributive property of multiplication over addition. So if we have a rational number, say something like 2 by 3 multiplied with say 5 by 7 plus say we have 6 by 8. So okay, let's assume we have a situation like this. So we have a rational number A needs to be distributed over B plus C, right? So A into B plus C. So you need not, one way of doing it is, A into B plus C, like any mathematics, like any real numbers, A into B plus C can be written as A into B plus A into C. That's what everyone should be knowing. So A into B plus C, it holds distributive property. A into B plus C is A into B plus A into C. Now, if you want, we can prove this. How do we prove this? Now, let's do this first. Now, if we want to do this, 2 by 3 into 5 by 7 plus 6 by 8. One way that we can do is properly, it's 2 by 3. And I'm multiplying that with, let's do the addition inside. So when we do the addition, 7 and 8, LCM is 56. So you're into 8 here, right? So you understand that, right? Into 8 into 8. Therefore, 8 5s are 40 plus your 7 6s are 42. So if you simplify this, it's 2 by 3 multiplied with, now your denominator is 56 here. And what is the numerator? 40 plus 42. That should be 82. Right? So can I multiply this now? 2 1s are 2 how many times? 2 2s are 2 8s are. Is 82 divisible by 3? No, it is not. So your value will be 82 divided by 3 into 28. What is 3 into 28? 28 3s are. 25 3s are will be 75. So 3 3s are will be 9. So 75 plus 9 will be 84. Correct? 28 3s are. What is it? 28 3s are? How much?
84.
84. Yeah, we can further simplify this here. 2 4s are, 1s are, 2 41s are, 2 42s are, right? Perfect. So that value is 41 by 42. Okay. So that's how we have done the entire calculation. Another way of doing the same thing will be by distributive property. So what was your question? 2 by 3 times 2 by 3. Let me use a different pen. So 2 by 3 times of, we had 5 by 7 plus 6 by 8. Now let's use distributive property and check. So what we can do, what's the distributive property? What it says is 2 by 3 multiplied by 5 by 7 plus 2 by 3 multiplied by 6 by 8. So how can we do that? So when we simplify only this part now, this is separate piece. 2 by 3 into 5 by 7, 2 5s are 10 divided by 3 7s are 21. Plus this you can do 2 1s are 2 4s are. Once again 6 by 4 you can further do. You can see 3 1s are 3 2s are.
Sir, it would be 2 by 4, sir.
2 by 4 can press 1 by 2 also.
Yeah, 1 by 2.
So 10 by 21 plus 1 by 2.
1 by 2.
If you simplify, LCM will be 42. 21 into 2 will be 42. So 20 plus your 2 21s are 21 1s is 21. So once again you are getting 41 by 42. So you can see whether you do it like this directly or you distribute.